All right. Good day to everyone. So, this is strictly for sequences and series, and we are hoping to cover as much as possible as we can to ensure that we have everybody really sound in this particular topic. Also, if you have no idea about this topic, this is your opportunity to learn every detail about sequences and series. It's quite very simple. One of the simplest aspects of mathematics. It comes with just understanding the formulas and knowing how to go about things. All right. So you need to relax yourself. Make sure you are calm. Make sure you are in a perfect environment. Make sure you have yourself in the right order because this is a topic you really enjoy. And it's quite very simple. There's nothing about sequences and series. Just calm your mind and see how great you're going to get in this topic. All right. So when you talk about sequence, these are what we use in our everyday today life. It's more like when you are able to establish a pattern in something, probably a number. Like for instance, imagine I wrote something like this. If I wrote two, if I wrote four, if I wrote six, if I wrote eight. By the time I stop at eight, I'm sure everybody right on this live stream can tell me the next number because you have been able to establish a pattern. You have seen a pattern going on. You've seen something happening. So this is what we call a sequence. This is a sequence. It's a sequence of something happening. So sequence is actually like a list of numbers, probably objects, probably events that comes one after the other. And in almost every case, there is a definite order. That means the next term is formed according to some certain rules. Like in this case, in this particular one I wrote now, you can see that the rule going on here is that you're adding two to the next term. So when you added two to the first term, you got the next one. You added two again, you got this one. You added two, you got this one. You added two, you got this one. That's the rule going on here. Another case could be different. You may have something like this, and so on. Now, if I stop at this place, I'm sure everybody on this feed probably should be able to establish a pattern going on already. And it's different from the very first pattern. It's far different from the very first pattern. And if I tell you to complete this, if you are, I'm sure if you're very patient and you are careful enough to study this, you will see that the next number is going to be 243. Not because of any other thing other than you were able to find out the pattern going on. So you saw that in this case now we're multiplying by 3. So we said 3 times 3 we got 9. 9 times 3 we got 27. We saw it was moving on that way. 27 times 3 we got 81. So to fill in this one, you just needed to do 81 times 3. That's the definition of a sequence. So you find a pattern, you find like a rule going on, and then you are able to predict the very next value. And one of the things you'll be doing in this particular topic is, for instance, they could ask you, in this case now, to go on and find the 10th term. Now, the difference here is that if you are trying to find the 10th term by doing it the manual way as we were doing it, probably multiplying by 3, and you want to find the 10th term by multiplying this by 3, another 3, of course, that'll be tedious. That'll be very tedious. Before you get to the 10th term, you would have spent much more time. And imagine they then tell you to find the 20th term. Of course, that's also going to be much more tedious. So that's the reason why we have certain formulas that has already been established that will help you to get these perfect values. So that's why we'll be talking about some formulas. So when we talk about those formulas, all you need to do is to just get them into your mind and understand them, and then you are good to go. Now, what do we call a series? Actually, a series, we say sequence and series. A series is actually the addition of all the terms of a sequence. So if you had all the terms of a sequence, we get a series. That's just that about that. So we have a finite sequence, and we also have an infinite sequence. In the case of a finite sequence, you will have, like, for instance, imagine I wrote this. Imagine I wrote this, and I said dot 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 10, and I said the last term was 10. So if I say the last term was 10, obviously you can see this is a finite sequence. It has a starting, it has an ending. It's finite. Meaning of finite means you could count it. It's countable, it's not uncountable. But for that of an infinite sequence, all you will just see at the end of an infinite sequence is that you will see something like dot dot dot. That means I'm not going to tell you an end. I'm not going to tell you where it stops at. It keeps on going. That's an infinite sequence. All right. So these are some of the basics that you have to know now. And when you have a sequence that you can't establish a mathematical relationship between the consecutive terms, that means you see a sequence happening. Something like that used to happen where you see a particular sequence, but the sequence doesn't have a particular order. That means the next term wasn't on the basis of what happened in the previous term. It's in that case we call it a recurrent. A recurrent. That's a special type of sequence called a recurrent, where we can't establish a rule that works for all of the terms. So if your nth term cannot be written in form of a function of n, but as a mathematical relation of consecutive terms, that sequence is called a recurrent. All right. Now, I would quickly identify to you that we have 3 different types of sequence we'll be doing right in this particular lesson, in this particular tutorial. And I don't want to take you through too much of the peripherals. I'm sure you are interested in the meat of this particular topic. So let's delve very quickly into the types of sequences we have. Well, the very first one we have is what we call the arithmetic progression or the arithmetic sequence. For those of you talking about you probably want to know the peripherals. I would love to talk about that at the end of the class. I don't want us to spend the early energy on things that I'm sure you can all relate to. It's quite very much easier to comprehend. I want to go into the part where you have a lot of word problems. You have a lot of different things going on. That's what I want us to focus on in this particular class. So we have 3 different types of sequences we'll be talking about. The very first one is what we call the AP, the arithmetic progression. The next one is what we call the GP, the geometric progression. And the last is what we call the harmonic sequence, harmonic progression, HP. Now, these 3 different sequences, we'll be talking about them distinctively because they all have their particular rules that goes on with them, and you have to understand them. So let's start from the base one, and that's the arithmetic progression. The arithmetic progression is that type of sequence in which you deal with more of addition and subtraction. That's the arithmetic progression. And the geometric progression has more to do with multiplication and division, while the harmonic progression is when you deal with the reciprocal of an AP-like sequence. Anyway, when we get into the meat of this, you will get all the details around all this. Now, let's talk about an arithmetic progression. In an arithmetic progression, there are two things you must never forget. Two key things you must never forget. Two key things. Number one is that the first term of an AP is termed as A. And then we also have something we call the common difference. Did I not just say that when we're dealing with AP, arithmetic progression, we deal with sums and differences, while in GP we deal with multiplication and division. But for an AP, we focus more on sum and subtraction. Now, how do we write the general term? When we say the general term, more like the nth term, more like it's like we have, look at an instance, 2, 4, 6, 8, 10, dot, dot, dot. How do we write? This is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. Now, we have to be able to define what we call the nth term. So in an arithmetic progression, the nth term, which is termed as un, is always seen as this. Sorry, n minus 1 rather. This is one of the first formula you have to note. You have to note this formula and take it wherever you go. That the nth term of any arithmetic progression is written as this. Now, let's see how it works very quickly. Let's see how it works. We have a basic example right in front of us, 2, 4, 6, 8, 10. That's a basic example. I'm sure everybody can understand that this is an AP going on in this way. We are adding 2 to every of them. So what's going on here is addition of 2, addition of 2, addition of 2, addition of 2, and so on. So I can tell you that the next time should be 12. So this is an AP that I'm sure you can all relate to. Good. Now let's try and find these terms, assuming we don't know them. Now the first term is a very important term in an AP, and a common difference. In some cases, they will give you some certain things and ask you to find those terms. They can give you maybe the fourth term, they can give you maybe the third term and say find the first term. But in any case, the first term is always very vital in an AP. Let's see what happens here. Let's assume I know my AP to be, my first term to be 2. Imagine I'm told to find the fourth term, assuming I didn't know the fourth term. And I know my AP, that means I want to find my U4. And I know my A is 2. My A is 2. And obviously my common difference is 2 also, because I'm having an addition of 2. So A is 2 and D is 2. If I'm trying to find the fourth term here, I insert my A as 2, that will be 2 plus. I'm trying to find the fourth term, my hand here is 4, then 2. In this case, we have 2 plus, what's 4 times minus 1? That's 3. 3 times 2 is what? 6. That's 2 plus 6. That's 8. Do you see that it gave you the exact value you knew already? That's exactly how you do this. So you can obviously see that this formula is tested and tried, and it will work for finding the nth term of any arithmetic progression. So you have to note that term, that formula, very, very vital. All right, let's talk about another formula. I told you that you have to pay attention to certain formulas. These are non-negotiable things you must know. Let's talk about the sum of terms. We'll still use the same. This is the nth term of an arithmetic progression. If you're taking notes, this is the nth term that I just wrote. Now, let's determine that we want to find. We have 1, 2, 3, 4, 5. Let's assume we had just 5 terms here, and so on and so forth. But let's say we had that one. There are situations where you would have to find the sum of the first a particular number of terms. I want you to understand the distinction between all these things I'm saying. So what I want to talk about next is the sum of the first n terms. The sum of the first n terms. In this case now, we have 1, 2, 3, 4, 5. So let's assume we had this AP and we're trying to find the sum of the first 5 terms. So let's use the manual way, then we'll use the formula. By the way, let me write the formula for you. The formula for use when you want to find the sum of the first n term is actually, you term it as Sn equals to what? N over 2. You have to note this. This is the formula you have to know. 2a plus n minus 1d. This is the formula right here. So what we're going to do now is we're going to use the formula, we're going to use our manual way for you to understand how this formula works. It's for you to find the sum of the first a particular number of terms. In this case now, we can use it for the sum of the first 3 terms. That will be 2 plus 4 plus 6. If we use it here, you will see it to give you the same answer. Obviously, let's try for the first 3 terms. The sum of the first 3 terms by manual means is 2 plus 4 plus 6. That's 12. So the sum of the first 3 terms using our manual means is what? 12. Now let's use the formula means and let's see what happens. Now we have n divided by 2. Sum of the first 3 terms. That means n here is 3. So we have 3 over 2. Our first term was 2. That's 2 times 2. That's 4 plus. Our n was 3. Don't forget. 3 minus 1. That's 2. And our d was what? Our d was 2. Let's see if this is going to give us the result we're looking for. 2 times 2, that's 4. 4 plus 4, that's 8. This will be 3 over 2 times 8. This will be what? 1, 4. 4 times 3, 12. Do you see? Now this formula works perfectly for finding the sum of the first. I'm emphasizing on the word first because you need to understand the use of each of these formula. When you hear that word, the sum of the first maybe 5 terms, maybe 20 terms is something. Understand that this is the formula you refer to in that case. In some cases, they will tell you, they will give you the A value, the first term, they'll give you the D value, the common difference, and they will tell you to find the sum of the first 20 terms. That means they're asking you to add up the first 20 terms. Obviously, in that case, we could use the manual means in this situation because it's a small question. But imagine you're asked to find the sum of the first 20 terms in this place. Can you recognize how tedious that will be? So that's why we need a formula like this that will help us to just find, if we were to find the sum of the first 20 terms of this term, let's try and apply this quickly. And I want you right there with your own note, try and find the sum of the first 20 terms of this particular sequence. I'll be doing my own right here. You can do your own where you are. Let's see how this works. The sum of the first 20 terms. The sum of the first 20 terms. It's not rocket science. It's something you can easily do. Of course, in this case now, you're dealing with n as what? 20. So in this case, if I'm trying to find S20, I'll be having 20 over 2. 20 over 2. Then don't forget my hay is what? My hay is 2. That'll be 2 times 2, that's 4. 4 plus 20 minus 1, that's 19 times what? 19 times 2, my D was 2. What do I have here? I have 10. Of course, this goes here. We are left with 10. This is 10 times 4 plus 38. Am I right? That's 4 plus 38. 38 plus 4 is what? That will be 42. That will be 10 times 42, and that will be what? 420. Do you see how many lines we use to find the sum of the first 20 terms? Rather than going through all the manual means, this is how we find it. All right, that's that about that. We can move to the next set of work. Now, There's another aspect of AP you need to look at, and that's the aspect where you're told to find the sum of the last n terms. The sum of the last n terms. There's a formula for that also. I told you earlier that one of the key to succeeding in this particular work is to have is for you to have a good understanding of all the formulas and know exactly how to use them. So I want to talk about the sum of the last n terms now. The sum of the last n terms. What is the formula we use there? All right, the formula we use there is all right. Now you see this particular situation now where you have whatever question you are finding. If you are told, and the word used is, they told you that there was, of course, when you're talking about this particular formula, you're dealing with a situation where you're dealing with a finite set, a finite sequence, because that finite sequence obviously will have a last term. An infinite system, sequence, there's no way you're going to be talking about the last term. So in this case now, when you have a question where you have the last term being told to you, and you have to find maybe the sum of a particular number of terms, which is from the first to the last. In that case, this is what you use. Don't forget, the last one we solved is the sum of the first maybe 20 terms. But in this case, you are asked to find the sum of the last n terms. So this is how you use it. You'll be seeing a question on this very soon. And let's delve quickly into applications of arithmetic progression. We have a lot to do, so I want us to move as fast as we can. All right, take this question now. We have 4, 7, 10, 13, and 16. All right, I'm sure you are flowing with the class. You're supposed to become a professional when it comes to sequence and series at the end of this class. So make sure you're taking good notes. All right, we have this question. We have 4, we have 7, we have 10, we have 13, we have 16. We have 4, 7, 10, 13, and 16. Then we obviously have a continuation. So this is obviously an infinite sequence. Question number 1, you are told to find the common difference. Question number 1 said, find the common difference. Obviously, find D. I'm sure we all know what the common difference represents. Question number 2, we are told to find the nth term. The nth term. And question number 3, we're told to find the 21st term. We're still on AP. Don't forget, AP is that part of sequence where we deal more with addition and subtraction to get our difference. While GP, we deal with multiplication and division. Now, how do we find the common difference? Pay attention to this real good. If you're finding the common difference, it's easy to use your eyes, but I would advise you, because you don't want to do that for every question, try and use a mathematical means to get the common difference. So how do we do that? Well, let's try and analyze all this work. Of course, from what I have here, I can clearly define that my A is 4. My first term is 4. I'm sure you all agree with that. And my second term, this is my first term, U1, which is A. My second term, U2, okay? I think I needed to have explained something to you guys. Don't forget, let me do a little digression. I told you that the general formula was UN equals to A plus N minus 1 D. Of course, if you look at this now, you can see that from this particular formula, if I was going to find my u1 here will be equals to a plus 1 minus 1, because n here is 1 times d. 1 minus 1 is 0. 0 times d is 0. That will be a plus 0. That will be a. You can see that my u1 is obviously a. Let's try and find for u2. We're finding for u2, this will be 2, and this will be 2 minus 1. In this case, this will be 1 times d. So obviously, this will be a plus d. That's for u2. Let's try and find for u3. Let me write it here. u2, we got a plus d. For u3, if we were having u3, what's it going to be? u3 will be a plus, my n here is 3. That will be 3 minus 1d. That will be 2 times d, because 3 minus 1 is 2. That's 2 times d. That will be 2d. That means my u3 is a plus 2d. All right, let's see for u4. You will see the pattern right now. u4, obviously, my n is 4. I have 4 here. 4 minus 1 is actually 3. That will be a plus 3d. Now, that's u4. Let me just submit to you that if you go on and on and on to keep on doing this, you can see the pattern going on here. When you had u1, you had a. You had u2, you had a plus 1d. That was u2. u3 was a plus 2d. u4 was a plus 3d. I'm sure if you keep on doing this, if you do for u5, I'm sure you people will not argue with me that it's supposed to be a plus 4d. If I go on to do for u6, it's going to be a plus 5d, and on and on and on and on and on. We keep doing this, we keep getting the same pattern. All right, this is nice. So why did I have to bring this up here? Because I want you to always use a mathematical means to arrive at your answers. I don't want you to always be using the reasoning way, just looking at it and saying the common difference is, and then doing calculation. I want you to use mathematics to always arrive at a value for d and a value for whatever you need to find. All right, so I'm sure nobody argues with me that I have my u2 as a plus d. Now, from what I have here on the in front of us, I can see a plus d, which was the second term. This is u2 second term, was equals to 7. Of course, my a, my first term, was equals to 4. So looking at this, I can see that a plus d equals to 7, but my a was equals to 4. If I put this here, I will say 4. If I put a as 4 into this first equation, I'll say 4 plus d equals to 7. My d is 7 minus 4. My d equals 3. So obviously, I'm sure you agree with me that the difference here, the common difference among this sequence is d being 3. Now, you can use your normal logical way to get your answer there, because if I look through on all this, I can see that an addition of 3 to all of them was giving me the next value. 4 plus 3 gave me 7, 7 plus 3 gave me 10, 10 plus 3 gave me 13, 13 plus 3 gave me 16. So obviously, it's established the common difference is 3. My first answer, my first question gotten. All right. Now I know my A is 4. I know my D is 3. I was then told to find the nth term. I was told to find the nth term. All right. Good. How do I find the nth term? You already know the general formula for the nth term. I said it, the nth term general formula for a sequence, an AP, is given as un is equals to a plus n minus 1d. This is for any sequence. But don't forget, let me tell you this. You can find specifically the nth term of particular sequences. Of course, still referring to this general term. This is general for any sequence. But you can, for any AP, arithmetic progression, but you can go on to find specifically for equation. So in this case now, the nth term for this particular one, you will be using this formula. That will be a plus, my a now is 4. The nth term, I'm solving the equation 2. Nth term will be 4 my a plus, what's my n? That's why it's called an nth term. I don't know my n. So you fill in your n as n minus 1. My d, I got it as 3 times 3. So if you go on solving this, what do you get? Of course, you will get 4 plus 3n minus 3. 4 minus 3, of course, this is 4 minus 3. This will be 3n minus 1. Is it minus 1? Sorry, plus 1. 4 minus 3 is plus 1. So can you see how easy that is? This is the nth term of this particular sequence. Note that this is based on this particular sequence because this sequence had an A of 4 and a D of 3. So the nth term for it is what we have here. And believe me, you can use this 3n plus 2 now for this particular term to find any term. Now, it takes us to question number 3. We're told to find the 21st term. Now, if you go on to use this particular equation, you will still get an answer, let me assure you. But since I know my nth term based on this particular question, I can use this also. Of course, this was derived from this. So if I start from here, I'll get an answer. But at this point, I think I'll prefer us using this because why not? That is the reason why we got it. So we have an nth term now for this particular sequence. So if I want to find the 21st term, that means I want to find U21. Of course, I know my UN. This is my UN for this particular question. So my U is 3n plus 1. So my U21 will be 3 into 21 plus 1. And if you fix this on a calculator, what is 3 times 21? We're having 63 there. That's 63 plus 1. That is what? 64. Very simple. We have gotten our 21st term. This is how you dissolve sequence and series with no issue at all. Just follow the protocol. Note the formulas. Apply it the right way. You could never get it wrong. You could never. Now let's see how to. You can go on to enjoy yourself trying to find any number of terms. Even you can decide to use this particular sequence to try and find a term you already know. 1, 2, 3, 4, 5. Go on to find U5 and say, let's see if it gives you 16. Can you try that? What is U5? What is the fifth term? Use this particular nth term and see how it works. Use U15. Try and get U15. U15 will be what? U15 will be 3, 15 plus 1. That's 45. Is that 45? Ha! I say U15. U5 rather, sorry. Finding the fifth term, not the 15th term, sorry. That will be 15 plus 1. That's 16. That's it right there. So you can see it works perfectly well. It works perfectly well. So let's quickly run to another question. Now, this one I expect you to do it even before I get to hit. You have this sequence -3, 2, 7. -3, 2, 7. And you have to find, this is the sequence, -3, 2, 7. This is the sequence. Of course, it's an infinite sequence, so it keeps on going. So you're then told to find the 10th term. The only question here is for you to find the 10th term. Now, I want you to follow the same process I followed. The same process, find the common difference first. Find the common difference, you tell me what the common difference was. Then go on to find the nth term, of course, so that you can get more perfect in all of this question and you are very much familiar with the use of the words. So find the 10th term, but first of all, find the common difference. Then go on to find the nth term. Then go on to use that nth term value to find the 10th term. Can you do that very quickly and let's move from here? All right, what's your common difference? How do you get your common difference again? Now, I know that my U1 here, which is indicative of my first term, is equals to A, which is equals to -3 here. That's, of course, very clear. Now, I can see that my U2, which is equals to, as I said earlier, A plus D, I can see it was equals to 2. Okay, let me try and find my common difference here. Since I know that A plus D, which was my second term, this is the formula for the second term, is 2. And I know that my A is -3. That will be -3 plus D equals to 2. My D here is equals to what? 5. Okay, now I have my D as 5. Can I go and find my UN? That's my nth term. My nth term will be, of course, I'm using A plus N minus 1D. What is my A here? The A here is -3. minus 3 plus my n. I don't put a value there because this is nth term. So I have n minus 1. What is my d? Times 5. This is minus 3 plus 5n minus 5. Minus 3 minus 5, that is 5n minus 8. Now I want to use this 5n minus 8 to go on to find the 10th term that I was told to find. All right, my 10th term now, this was un. For this particular, don't forget, this un is based on this particular sequence, not for every other sequence. This is based on this particular sequence. Of course, the general term for every sequence is what I wrote initially. All right, now for you to find your U10, what you have to do here is to go on to 15, 5 times 10 minus 8. This is 50 minus 8, and this gives me a value of 42. You can never go wrong if you follow the right procedure. So let's move on very fast. Now let's try and solve a much more technical question. This is, once you understand all this detail, then solving any form of technical question becomes far more easier for you. All right, now the 4th term and 6th term, I want you to get this, and you keep solving as much as you can, and I'm going to solve mine also. Now the 4th term and 6th term of a linear sequence are 8 and 4 respectively. They said the 4th term, the 4th term and 6th term, the 4th term and 6th term, 4th term, 6th term, the 4th and 6th term of a linear sequence. Of course, when you hear the word linear sequence, I want you to understand that that is an arithmetic progression. That's another name given to arithmetic progression, a linear sequence. So it's, please take note of that so that you don't get confused. So when they say a linear sequence, you're always referring to an AP. So they said the 4th and 6th term of a linear sequence are 8 and 4 respectively. That means the 4th term was 8 and the 6th term was what? 14. We are then told to compute the 1st term and common difference. So you are told to find A and D based on this information you are given. So you're given that the 4th term is actually 8 and the 6th term is 14. How do you find A and D? All right. Of course, you have to use what you know to get to what you don't know. I know my 4th term, and I know the formula for my, this is U4, this is U6, and I know from what I was saying earlier, if I had U4, I'm sure this is what it's going to be. U4 is A plus 3D, as I said earlier, and U6 will be A plus 5D. It's just normal. It follows the same pattern and procedure. Now, I was told that U4 was 8, and I was told that U6 was 14. Looking at this, I can easily notice that I'm already having like a simultaneous equation, because now I have A plus 3D equals to 8 and A plus 5D equals to 14. So I can decide to use any method of simultaneous solving simultaneously to solve this. All right, when I look at this now, I can see that if I make use of subtraction, I will easily eliminate the A. So I'm left with what? Minus 2D equals to what? Equals to minus 6. Am I right? You are subtracting. That will be 3D minus 5. 3D minus 5 is minus 2. 8 minus 14 is minus 6. My D here will give me a value of what? 3. So I get my D to be 3. That's very easy. I've gotten the first one. D is 3. It's no longer a mystery. Now, how do I find my A value? I can decide to use any one. I can decide to use this one or this one. I fixed in my value of D being 3 into any of them, and I'll get my answer. So if D is 3, and I know that A plus 3D, no more D now, I'm going to put 3 there, is equals to 8. That will be A plus 9 equals to 8. That will be A equals to 8 minus 9. My A here is what? Minus 1. Can you indicate if you got this right? Anybody got this right? This is the way you solve these questions. Confidently, you never go wrong. Confidently, you never go wrong. All right. Now let's see this question very quickly. We don't have much time. Uh, the first term of an AP is 7. First term. The first term of an AP is 7. Now they said the last term is 70. The first term is 7. The last term is 70. The first term is 7. They're solving a new question here. The first term is 7. Of course, A equals to 7. First term, that's U1, which is A. And the last term, L, let's call it L, is 70. The first term is 7, last term is 70. They now said, and the sum of the series is 385. Pay attention to this. When they said the sum of the series, did you see that they said the sum of the series? Do you remember what I defined a series as at the beginning? I told you, I made a comment on what a series is. I said a series is obtained by adding all the terms of a sequence. A series is obtained by adding all the terms of a sequence. You see, once you get all these things noted, you can easily write on any question, either a word problem, whatever, because you would know exactly how to go about things. So when you hear the word there that they said the last term of this, or they told you that the last term was 70, then you were then told to go on to that the sum of the series was 385. The sum of the series. That means the total sum of the series. In this case, Sn, whatever n was, that means this series was obviously a finite series because we have a last term. So this was a series that had a last term. It's more like, imagine I was writing this, I will write it. If I wanted to write this in series form, I'll write 7 dot 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 770. It started from 7, it ended at 70. So this is a finite series. So we're then told that the sum of this series, all of them, from 7 to 70, was 385. All right? The question then told us to find the number of terms in the series. So we are asked to find n. This is our question, find n. And then question number 2, we're told to find a common difference. We're told to find the common difference. So these are the two tasks before us, finding the number of terms and finding the common difference. Now we're given the first term, we're given the last term, we're given the sum of the series, which is the addition of the entire sequence from the first term to the last term as 385. All right. How do you do this? I gave you a formula earlier, and I told you that when you are told to find the sum of the last n terms, in this case now, all the terms here is the sum is 385. I gave you two formulas. I said one was the sum of the first n terms, and one is for you solving for all of the sum essentially, because when you have the formula, this was the formula I gave you, if you remember precisely. I told you that Sn then was n over 2 a plus L. I gave you this formula some minutes back, and I told you that this formula is used for finding the sum of the last terms. So in this case now, this represents all the terms, the sum of all the terms. This is when you have a last term given, this is when you use this formula, this particular formula. Because when you have a last term, obviously, you can take your sum from the beginning till the last term. That's when you use this formula. But the other one I gave you is when you are told to find the first, a certain number of terms. Maybe the first 20 terms, the first 6 terms, the first 10 terms. That's when you use that other one that I gave you. But when you have a last term given, obviously, in that case, you know the last term. To find the sum of that is when you use this particular formula. So when I look at this particular question, I know this Sn. Of course, I can identify with this Sn. I know this Sn. They gave me this as this 385. They told me to find my n. Of course, I know my first term, I know my last term. So obviously, you see the question is almost solved already without so much, without any struggle, because all you need to do here is to have 385 is equals to my n here. I do not know. That's the very first question. N over 2. And we have the first term as 7 plus my last term as 70. So we have 385 equals to n over 2, 77. So what we have here is 385 times 2. What is that giving us? Of course, cross multiplying that. When you cross multiply 385 times 2, we have 770. So 770 is equals to 77n. Wow. I can see my answer already. Dividing both sides by 77, I have my n to give me what? A value of 10. N gives me a value of 10. So this is where you solve these questions, essentially. You just have to use what you know and make sure you keep your formulas close to you. You need those formulas, because imagine you did not know this formula and you're given a question like this, you will not know exactly what to use. When you have a last term, this is the formula you use when you're trying to find the sum of the terms. All right, how do we find a common difference? How do we find a common difference? Now, with what I have here, you can see that my n equals to 10. So that means I was told now that from this particular answer here, that I got n being 10. Because I got n being 10, please pay attention. Because I got n being 10, don't forget the use of the word n means the number of terms. So that means from this particular answer now, I know that my number of terms here is 10. And that means I know that this particular term is the 10th term, because it's the last term. So if I have 10 terms in a particular sequence, of course, the last term will be the 10th term. I don't think that's rocket science. If I have 10 terms in the sequence, which is what we just got, because the question said find the number of terms, we got n as 10, and I have 70 as the last term. Obviously, 70 is the 10th term. That means 70 represents U10. So if 70 represents U10, and don't forget, my formula for U10 is going to be A plus 9D. Now I know my U10 to be 70. That's 70 equals to what's my A? My A is 7 plus 9 times the D I'm looking for, which I do not know. So I take out, this will be 70 minus 7 is equals to 9 times D. What is 70 minus 7? That will be 63. 63 equals to 9D. And my D here will be equals to what? My D will be equals to 63 divided by 9, which is what? 7. So this is how you solve questions confidently. You have to just make use of all the data you have, and you could never go wrong. So my D here is 7, my n is 10, and that's the solution. But I want to bring to your attention that the formula that solves for the first n terms can also work in this case, because it's more like if I use this formula or I use that of, somebody is asking how do I know that 70 is the last term? Because I know that, because how do I know that 70 is the last term? That's actually from the question. It told me that the last term is 70. It was told in the question that the last term is 70. So that's from the question. Yeah, what I was trying to say is you could actually make use of the other formula of the sum of the first n terms. You could actually use this, and it's actually also going to work. I don't need to use that, but if you want me to use it, of course, it will also work. And through that, you can use it to get your D. So that's just that's about that. I've not seen the question somebody asked last. How do you know? I got n as 10, and that's the question. The meaning of n means the number of terms, and so if my number of terms is 10, then that means if the total number of numbers I have in a sequence is 10, and I know that my last term is 70, obviously that means my 70 represents my 10th term. It's just basic. That's just basic logic. All right, I want you to solve this under 1 minute. I want us to start working with speed now. And so I want you to evaluate the nth term and the sum of the first n term of this particular AP. I want you to find the nth term and the sum of the first n term of this particular AP, and then you then go on to find U11, that means the 11th term, and S20, the sum of the first 20 terms. Now this is a question that is quite rich, so I want you to deal with this accordingly with confidence, and show me that you have been paying attention in what we've been doing, and you've gotten the right knowledge. So I want you to try and solve this, of course, while I'm also solving. So pay attention to the question. You are told to find the nth term and the sum of the first n term. It's quite a very interesting question. And the terms we have 3, I think 7, 11, 15. It's an infinite sequence, so we have it on and on and on. So you're told to find the nth term. Very first question is for you to find the nth term. Nth term, that's the first thing you have to find. And then you're supposed to find the sum of the first n term. That means you're supposed to find Sn. These are the two questions. And then after you're done with this, you're then told to find the 11th term and then the sum of the first 28th term. These 4 questions, can you solve it in like 2 minutes? Quite very simple and straightforward. So I expect you to be solving while I'm trying to do mine here also. So I will keep solving mine, keep solving yours, and then let's try and balance our work together so that you can get mastery in this particular subject. Of course, I want to find my nth term. To find my nth term, I need my common difference, because my nth term for the general nth term is given as a plus n minus 1, a plus n minus 1 d. So obviously, I want to find the nth term for this particular sequence. This is the general nth term. I want to find that of this one. So I know my a, my first term, which is a, I know it to be 3, but I don't know my common difference. So I have to go on to solve the common difference. How do I find the common difference? I know that my second term is a plus d, and it was 7. So obviously, if a plus d equals to 7, and a is 3, that will be 3 plus d equals to 7. That means d equals to 7 minus 3, which is equals to 4. So I've been able to get my d. So from here, I can easily get my nth term for this particular sequence as my first term being 3, that will be 3 plus n minus 1, because I don't know my n, then my d being 4. This will be equals to 3 plus 4n minus 4. 3 minus 4 is actually minus 1. That will be 4n minus 1. So this is the nth term for this particular sequence. This is the nth term. Now, we can keep that aside, and of course, tick. How many of you got this while solving? So we can go on to tick that we are done with. We are done with the nth term. So we're done with the nth term. So we can go on to try and find the sum of the first n term now. So this is the nth term, 4n minus 1. All right, good. That's good. I can see some people are flowing. I want everyone to be flowing. So let me try and find. Now I know my A value. My A was 3. My D was 4. And I want to find the sum. We have to manage the space we have. So just bear with us. We have A being 3. So A is 3. And my D was 4. I want to find Sn now. So from what I have, the general Sn, the sum of the first n term of an AP. Of course, don't forget, there's a general Sn that's existing already. And that was what we gave as this. We said this was the general Sn of any AP. This was what we said as the general Sn. Well, in this particular case now, we're trying to find the sum of the first n terms of this particular sequence. So we have to find a specific value, a specific function for this sequence. So what do we do next? We use this formula, the general formula, to try to arrive at our own sum of the n term of this particular sequence. So we have our A as 3. So don't forget, we can't fill in a value for n. Don't forget, we're finding the sum of the first n terms. So we don't know an n value. So n is a mystery here. We don't have an n value. So n remains as n. So what we then go on to do is Sn will be equals to n over 2. 2 times what's my A, 3, plus n remains there. My D was 4. So I go on to have this as n over 2. 6 plus 4n minus 4. I'm opening the brackets immediately. So what do I have here? N over 2. 6 minus 4 is what? 2. That'll be 4n minus 2. All right. What do you think you need to do next? You can obviously factorize 2 outside. I can factorize 2 because I can see 2 is common here, 2 is common here. So if I factorize 2 outside, I will have n over 2 times 2 into bracket 2n minus 1. Of course, I'll factorize 2 outside now. Then this 2 can cancel this 2. I'm left with n into bracket 2n minus 1. Okay, should we leave it there? Of course not. We can have a final answer as 2n squared minus n. How many of you have arrived at this answer as the sum of the first n term? The sum of the first n term. Okay, the sum of the first n term. How many of you was able to arrive at 2n squared minus n? All right. All right. So we have, don't forget, we had our un earlier. We had it as 4n minus 1. We had our un as 4n minus 1. And we now have our Sn to be given as 2n squared minus n. So now I'm told to find the last two. I'm told to find the sum of, I'm told to find u11. What's going to be u11? U11 is actually going to be, of course, we are using this term. That will be the nth term. So what we have here will be 4 times 11 That will be 4 times 11 minus 1. That will be 44 minus 1. That will be 43, I guess. How many of you got that value, please? 43 as your 11th term. Then what did you get as your 20th, the sum of the first 20th term? Okay. So who has gotten a value for the sum of the first 20th term? Okay, somebody has gotten it to be what? Somebody got 820, somebody got 780. Okay. All right. Let's examine this together. Oh, sorry. You guys did not observe. I wrote, look at, we have 6 minus 4. This was a mistake. It's actually supposed to be plus 2 here. Plus 2. Plus 2. This will be plus 1 then. This will be plus 1. This will be plus. Of course. Thank you for that. So the sum of our first 20 term will be given as 2. Of course, our hen here is 20. 20 square minus 20. This will be 400 times 2 minus 20. This will be 800 minus 20. Sorry, plus 20. That will be 820. All right. All right. So we have, now I should be able to say now that, because we have just one more thing to touch and we're done with arithmetic progression. Just one more thing, and that's all. So let me ask here the feedback now from everyone here. How do you feel now about the subject of arithmetic progression? Do you feel much more better? So the answer is actually not 780, but actually 820. So do you feel much better with arithmetic progression? Please let me get feedbacks, please. I want to go to the last aspect of arithmetic progression, which is the arithmetic mean. Very, very important. These are, can I please get feedbacks from everyone present? Okay. All right. Is David right here? Is David there? Is David here? I would love to hear what David has to say. So we want to talk about arithmetic mean, and very simple, but it has some aspects that you have to also be very careful about so that you never go wrong. Okay, very simple. All right. S20 is not actually 780, please. It's actually 820. So we're actually on AP right now. We are probably going to still touch GP. Okay. So let's quickly talk about arithmetic mean. This is actually so simple, so straightforward. We don't have to even, but it's actually very examinable, and you need to be very careful about. You need to be very careful about examinable aspects of mathematics. So you have a question. Generally, when you talk about arithmetic mean, we're talking about uh, the way you generally will solve the mean of what you call the average. So let's say we have ABC. You can use any alphabet as three consecutive arithmetic sequence. Imagine there are three consecutive terms in an arithmetic sequence, A, B, C. Let's say they move together like that. In this case, I want you to know that the arithmetic mean of these particular three terms will actually be this B value. So B is the arithmetic mean here. B is the arithmetic mean. And obviously, if you observe from any arithmetic sequence you have, to get your value for B, all you have to do will be to do A plus C divided by 2. For instance, let's say I had 2, 4, 6. 2, 4, 6 as, of course, these are consecutive terms in a particular AP, right? I told you now that if you have situations like this, just observe that this 4 is the arithmetic mean. So if they gave you like this and they just said, what's the arithmetic mean in this particular case? All you have to do is just to say, 4 is the arithmetic mean. That's all. So 4 here is the arithmetic mean. Now, but in some cases, let's say you were not given, they just wrote X there. Let's say they just wrote X, 2, X, and 6. And then you are told to find the arithmetic mean. Of course, if you knew the common difference, you could use the common difference to get the arithmetic mean here. That means, imagine they told you that the common difference here is 2. Of course, you know that means this will be 2 plus 2, this will be 4. That will be easy to get. But in the case where you did not know the common difference, how do you find the arithmetic mean? Of course, look at what happens here, and let's see if it works. X here will be equals to the term before it plus the term after it divided by 2. That will be 8 divided by 2. That will be 4. Was it not 4 that was there? It just always works. Imagine I had 10, 12, 14. Now imagine I was not told this one and they put y in here. Just imagine they put y here. Y would be equals to, if I knew the common difference, I wouldn't need to do all this. But in the case where I didn't know the common difference, this is how we solve it. This will be 10 plus 14 over 2. That will be what? 24 over 2. That will be 12 as a number. My y was 12, which was what was there before. So arithmetic mean is quite very simple. You just need to understand what it is. Number one, if you had 3 consecutive terms, the middle value is actually the arithmetic mean. All right? And how you find it is by adding the previous plus the next divided by 2. Now look at a particular examinable part of it. You're given this question. Let me see how you fare with it. Find 6 arithmetic mean between 2 and 51. Find 6 arithmetic mean between 6 and 51. Between 2 and 51 rather. Find 6 arithmetic mean. Find 6. Now, okay, before you solve that question, let me tell you something. I need you to understand something. Just for you to get more detail around arithmetic mean. Now, I'm sure you understand how we write terms already. I'm sure you don't argue with me if I write that the first term is U1, and I say the second term is U2, and I say the third term is U3, and I go on and on and on and on, and I say the last term was maybe UN, for instance. Of course, if I say UN here, I'm sure you agree with me that UN minus 1 was the term before UN. I'm sure you agree with that. If UN was representing 100, if N was 100, that means the term before U100 would be U99. That's obviously fair to understand. Now, how do you understand arithmetic mean? I told you that it's actually the middle element. Now, if you're told to talk about the arithmetic mean between U1 and UN, of course, it follows the same pattern. This whole thing will represent the arithmetic mean. So the arithmetic mean between U1 and UN, these are all of them. These are all of them. It's the same protocol. So now, of course, if you wanted to find U3, sorry, if you wanted to find U2, U3 plus U1 will give you U2. So this particular question I just gave you is an example where you'll be able to understand it far much better using values that you can lay your hands on. So you're told to find 6 arithmetic mean, 6. Find 6 arithmetic mean, 6 arithmetic mean between 2 and 51. Find 6 arithmetic mean between 2 and 51. 6 arithmetic mean between 2 and 51. 6 arithmetic mean between 2 and 51. How do you do this? Now, let me ask you one question quickly. If you're trying to find 6 arithmetic mean between 2 and 51, 6 of them, so you had 2 somewhere, you have 51 somewhere. You are now told that, of course, don't forget, the arithmetic mean between 2 and 51 will be all the number of terms between them, just as you can see here. So all the terms in between U1 and UN were the arithmetic mean between U1 and UN. Let me say that again. U1 and UN, the arithmetic mean between U1 and UN were all the terms between U1 and UN. So we are told to find 6 arithmetic mean between 2 and 51. Obviously, those 6 arithmetic mean will be terms between 2 and 51. So obviously, what term, let me ask the trick question, not the really trick question, what particular term will be 51? Can anybody give that answer? What term will be 61? What term will be 51? Anybody? Let me see. Yeah, we know it's going to be the last term, but which particular term? You can really have, yeah, 8th term. I love that. Look at it. 6 arithmetic mean stay between. Let's try and put a dummy. 1, 2, 3, 4, 5, 6. Now, if I have 6 arithmetic mean between them, of course, this is the first term, second, third, fourth, fifth, sixth, seventh. This will be the 8th term. All right. It's the last term, but you can fix in a real number there as 8. So from what I have here, how do I go on to find my 6 arithmetic mean? Very simple. You use what you know to get what you don't know. I know my A is 2. You have to start from where you know. I know my A is 2. That's the first thing I know. And I also know that my 8th term, this is A, which was your U1, is 2. And I know my 8th term, which is U8, which was equals to A plus 7D. Nobody argues with this, because if you have been in this class, you remember that A plus 7D is what you will call your 8th term. I know that my 8th term is 51. Of course, from what I have here, I can easily find my common difference. Of course, if a plus 7d equals to 51, that means my a is 2, don't forget. So 2 plus 7d equals to 51. 7d will be equals to 51 minus 2. My 7d will be equals to what? 49. That means my d is what? 7. Now I know my d to be 7. Now I'm very sure you guys are smiling where you are, because to find the 6 arithmetic mean is now the easiest thing once I have my common difference. Because I told you what arithmetic mean actually means. It's just the terms between those whatever you are told to find. So when if I have xyz, and I'm told to find the arrangement between x and z, the one in between is it. And I could get this by just using the common difference. If I don't know the common difference, then I could get it by adding the previous value plus the next value divided by 2, which will always give me my answer. So in this particular case, I know my d, my common difference, to be 7 already. So I want to find my terms. So what do I have to do? All I have to do is to go on to keep solving. So I have to keep solving for each of these terms now. Don't forget, arithmetic mean are the terms in between. Whenever you are told to find the arithmetic mean, just all the terms in between is the arithmetic mean. So if you have to find the arithmetic mean between 2 and 51, you are told to insert 6. All the terms in between that 2 and 51, they are the arithmetic mean. So the very first arithmetic mean we have here, which is the second term, that's U2, will be, of course, that's A plus D. A plus D, my A is 2, my D is what? 7. So my A plus D is 9. My first term there is 9. My U3, that's A plus 2D. That will be my A is 2. 2 times 7, that's 14 plus 2. 14 plus 2 is what? 16. My next is 16. My U4, that's A plus 3D. That will be 2 plus 3 times 7. 21 times 21 plus 2, that's 23. Can you complete the rest yourself, or do I need to go on? U equals to A plus 4D. That's 2 plus 4 times 7. 28 plus 2, that's what? 30. U6 will be equals to what? A plus 5D. That will be 2 plus 5 times 7. That's 35 plus 2. That's 37. What do you feel? Tell me what U7 will be, everybody. If you're following, what's going to be U7? U7 is going to be what? That means your sixth arithmetic mean. We have inserted 5. What's going to be your sixth one? Your sixth one is 44. Thank you very much. All right. So this is how we are able to insert sixth arithmetic mean between 2 and 51. Quite very simple. There is actually nothing you have to do other than what we just did in this class. So I want to ask from everyone, do you still want to go on, or do you want us to just do a recap and then continue from GP and harmonic sequence in a subsequent class, or are you good to go? I'm game if you're ready. If you want to go, I'm ready. Do you still feel like going? Do we continue? I'm sure we're going to have diverse answers. People say yes, yes. Okay. Let me get candid opinion from everybody. We still have GP. We still have harmonic sequence to touch. Okay. So we should keep moving. All right. We keep moving then. We keep moving. Geometric sequence. How do you do geometric sequence? Is very easy. Now let me say one thing. We can't spend so much time on these other ones the way we spent on this, because I was trying to establish the understanding of sequences in this particular aspect of sequence and series. But in the next ones we will be doing, we'll be more fluent, because Now that you understand how these things go. So very, very simple. All right, we're done with arithmetic progression. Let's now talk about geometric progression, which another name for it is GP. You see, the difference between AP and GP, as I said already, is that under AP, you have more of addition. You see, if you go on to look at the pattern going on here, this is 2 plus 7, 9, 9 plus 7, 16, 16 plus 7, 23, 23 plus 7, 30, 30 plus 7, 37, 37 plus 7, 44, 44 plus 7, 51. You can see this is an addition going on. But under GP, you'll be dealing with more of multiplications. And that's just the difference. That's the major difference between them. And of course, the formula that you'll be using, for instance, the general formula will be different, and also the sum of the first n term will also be different. So those are the things we're going to be making changes to. And since you understand the application under AP, I'm sure you will well understand that under this very easily. We won't need to spend so much time in solving questions here, since we have established a very good background foundation for AP. All right, let's see what we do now. Of course, as I said already, we're dealing with GP. Now, in GP, we have two things that you must never forget. As I started in AP, I said the same thing. In GP, you have, very importantly, the first term, which we are going to be defining as A. Then we also have, now, not common difference, now we call it common ratio, which we term R. Very, very important. You need to understand the symbols, the nomenclatures, and everything. So the first term is seen as A. The second, the ratio, we term it R. Now let's talk about the general term of a GP. The general term of a GP, UN, of course, just like we termed in the previous aspect, we termed it as UN. In this case, we are also going to be terming the nth term as UN. Is termed AR raised to power n minus 1. You need to note this formula. These are things you must note. It always will come in handy. You have to get it right into your mind. Now, let me try and just give you a hang around, of course, how will this one flow? That means if we have U1, the very first term, U1 will be what? A raised to power, AR raised to power 1 minus 1. And that will be AR raised to power 0. Anything raised to power 0 is what? A. So we'll be having our first term as A, which we have defined already. Now let's talk about U2. U2, we have AR raised to power 2 minus 1. Here we have AR raised to power 1, which we will term AR. Now we have U3. Of course, AR 3 minus 1, that will be AR 2. Now, look at the pattern going on here. You need to understand this thing. If you look at this pattern and I tell you to write for the fifth term, of course, I'm sure you can understand the pattern, and I'm sure you know that the fifth term will be AR raised to power 4. The third term, the second term was AR raised to power 1. The third term was AR raised to power 2. The fifth term was AR raised to power 4. The sixth term will be AR raised to power 5. And the seventh term will be AR raised to power 6. Of course, you can see this is all conforming to our original general term that says that the term of a sequence is a har raised power one, in short, one less than the term. So if it was U7, here will be one less than 7, that will be U6. That will be 6 here rather. So if it was U5, this will be raised to power 4. If it was U4, this will be raised to power 3, because what's going on this in this power, what we are seeing right here in this power is one less than all what we're dealing with, one less than it. So when we had U2, it was raised to power 1. When you add U3, it was raised to power 2. U5 raised to power 4. U6 raised to power 5. U7 raised to power 6. If I say find for U10, that'll be a har raised to power 9. So it flows that way. It flows essentially that way, and you need to know how to groove with it. All right. So let me quickly say some other things, some other formulas. Some other formulas will be the sum of the first term of the sequence. I'm sure you expected that, because you needed to talk about the sum of terms in a GP. We talked about it under AP. We have to talk about it under GP also. So under AP, we have the sum of terms. Now, in this case, there is a dynamics to this, which you need to pay attention to, please. Under GP, the sum of terms will depend on the value of the common ratio. So I'm going to give you two formulas, and I'll tell you how to use them. So the sum of the first n term, we have a Rn minus 1 over R minus 1. Then we also have it as a 1 minus R raised to power n over 1 minus R. I will tell you when to use all of this. Very, very important. Now look at these two expressions. You don't need to sweat it. You can see clearly that this particular expression will be very nice for values of R that are greater than 1. Or sorry, greater than 0. If your value for R now was maybe 2 or even 1, I'm sure you know that this value will never get 0. You will never get 0 here. It will be very hard to get 0, except if your R was 1, it will be 1 raised to power whatever number of times. So you'll be having, it's more like, imagine R was 1. Let me write it here. Here R must be greater than 0, and here R must be less than 0. And you understand why. It's not rocket science. It's not something that, it's not any form of manipulation. It's just ideal. So if you had 1 as R here, of course this would be 1 raised to power. Let's say the term was 10. Now 1 raised to power anything will be 1. That will be 1 minus 1. So you see that it's still very ideal here. It's still very ideal here. Now, in many cases, you will not have your R to be even 1. Let's say, for instance, you had your, of course, having R as 1, it's going to be a constant value, if you understand what I'm saying. So having R as 1 is not feasible, because if you're multiplying by 1, you will not get any increment. So that means your sequence, imagine you are multiplying your sequence by 1. 2 times 1, 2, 2 times 1, 2, 2, you know, it's not actually feasible. So you know that 1 is actually not a feasible value for your common ratio in many cases. But let's say any common ratio, just put any value there. If it's greater than 0, it works very much for this formula, because you'll be getting a positive value here, and this will also work well, because a value greater than 0, of course, works well for this particular formula. But if it was less than 0 and you fix it here, I'm sure you see that you'll be getting more of a negative value as the sum of your first n term. So that's why we use this one where you see you are subtracting 1 from your value here. Of course, if the value is greater than 0, it works better. Here, you are subtracting 1 from it when it was less than 0. If you had a less than 0 value here, subtracting it from 1 gives you more of a positive answer. I don't know if you can follow what's going on there. So this is very ideal when you have your common ratio being less than 0. When your common ratio is greater than 0, you make use of the first one. So that's the distinction between when and how to use this particular formula. This is the sum of the first n term of any GP. So I've given you the general term of any GP. That was when we said UN was equals to ARN minus 1. This is the general term of any sequence, general term. But the sum of the first n term of any sequence will be this if your common ratio was greater than 0, and this if your common ratio was less than 0. Nice and neat. Nothing to worry about. It's a very simple aspect of mathematics. Now, there's another formula you need to note, and that formula is a sum to infinity of a geometric series, which we always term as S infinity. These are formulas you must know. Please, it's very vital you know them, because you will be seeing questions that would beg for their usage, and you have to have known them. So the sum to infinity is given as a over 1 minus r. You have to note this formula. So if you're told that the sum to infinity of a particular something is something and everything, of course, this is what you will be using. All right. And again, this will work for when your r is less than 0. Now let's try and solve one or two examples. And let's see how we roll with these. Are you guys ready? I'm sure you guys are ready. All right. You know what I'm planning to do? Because there's a question on AP I want to solve. And then this is what we're going to do. After we solve that particular question, we would now I've given you the basis of these particular formulas and how to use them. So we will pick back up on this probably some other days. So we'll just start from GP. I want us to complete a particular question on AP, and I see that the time is running very fast, and I don't see how we can complete GP. And if we can, maybe in 2 hours, in 30 minutes, less than 30 minutes time, then we'll do it. But I want us to solve that particular question on AP. Then we'll go on. If we still have time, we'll go on to solve questions on GP. But there's a particular question we must solve it on AP so that we can consolidate our knowledge on AP. Look at the question. It's a question that is very familiar in exams. And I want you to, so this is the concept of GP. And the next thing we'll be doing now is to solve questions on it. And okay, you know what? Maybe I'm going to change my mind. Probably we'll solve one or two questions on GP, and then we'll come back to this particular question I'm trying to solve so that we can apply what we have here first before we move to something else. All right. So I'll solve one question on GP, and then I'll run back to that question, and then if we still have time, probably we'll solve one more question before we call it a day, and then we'll pick back on this in a subsequent class where we will complete GP and harmonic sequence. So we're still good to go next week. Later this week we can still continue that. Probably on a Wednesday we can continue this particular class. So let me solve a question on GP. Look at the question and let me see how you're going to fare with this. The third and seventh term of a GP. The third and seventh term of a GP are 81 and 6 respectively. The third and seventh term of a GP. The third term and the seventh term of a GP are 81 and 16 respectively. Find the first term and the fifth term. Find the first term and the fifth term. Find the first term and the fifth term. So you are told that the third term as U3 was given as 81, and the seventh term, that's U7, was given as what? 16. We are told to find the first term and the fifth term. Now, my U3, obviously, that was my A raised to power 2, was 81. This was my A raised to power, my seventh term, which is A raised to power 6, was 16. This is from what I explained earlier. So how do I go on to solve this? Now, I'm looking at something. In this case now, you can't use simultaneous equation because you don't have additions. This is not a linear expression. So what you have to do is you have to be very smart. I saw that my U7, A raised to power 6 is 16. And I saw that my U3 was this. If I decided to divide U7 over U3, the reason for that was because I'm trying to see how I can see something. And I could see that if I divided this by this, I knew already that my A will be cancelled. I'll be left with only R. And when I'm left with only R, I'll be able to function better. So you have to move through that route and you will get your answer. So A raised to power 6 over A raised to power 2. The reason why I didn't do A raised to power 2 over A raised to power 6 is because I know that R raised to power 2 divided by R raised to power 6, I'll be getting R raised to power 4, which is essentially what I love to see. So that will be 16 over 81. So in this case now, you can see we are having, of course, here we cancel A. And then I'll be left with, of course, the law of indices. When you have R raised to power 6 divided by R raised to power 2, you'll be having R raised to power 6 minus 2. That'll be R raised to power 4. So I'm not wrong if I go on to write R raised to power 4 is equals to 16 over 81. All right. Now, what do I go on to do here if I'm trying to find my R? I just need to take the fourth root of each side of this equation. So I'll take the fourth root of this. Of course, you know that when you have raised to power 4, if you have raised to power 2, you take the square root. If you have raised to power 3, you take the cube root. If I have raised to power 4, I take the fourth root. So I take raised to power 4 here. So I'll be left with my R value here. And then don't forget, I explained earlier to you the meaning of all these things. When you're told to find the fourth root of something, all they're asking you to do is give me a number that when I make it in 4 places like this, x times x in 4 places, I'm going to get the value here. So of course, this is the same thing as fourth root of 16 over fourth root of 81. The fourth root of 16 will be 2. Of course, 2 times 2 times 2 times 2 gives me 16. And the fourth root of 81 will be 3. So I've gotten my R to be 2 over 3. Now, getting my R gives me a very great opportunity to get my A. So I can get my A easily from any of the equation I have here, anyone. I can use this or this. So my A R2 equals to 81. If this was the case, I put R as 2 over 3, and we have A times 2 over 3 squared equals to 81. That will be A times 4 over 9 equals to 81. If I decide to multiply both sides by 9 so that I can eliminate a 9, of course, multiplying both sides by 9, 9 cancels 9, and I'm left with what? 81 times 9. What is 81 times 9? 729. 729 divided by 4 will be 729 divided by 4. All right. So I'm getting my A value to be 729 divided by 4. So this is 729. A is 729 divided by 4. And that's it. That's how you get your values. So I've been able to arrive at my A value, my R value. That means my first term and my common ratio. But what's left now, they told me to find my first term. I've gotten my first term now, but I need to go on to find the fifth term. So how do you find the fifth term? The fifth term will be AR raised to power 4. That will be the fifth term. I'm sure everybody can solve that here. The fifth term will be AR raised to power 4. My fifth term will be AR raised to power 4. My A is 729 over 4, and my R is 2 over 3. So that will be 2 over 3 raised to power 4. So this will be something I think everybody should be able to solve. Can you go on to solve this and try and see what you're going to get? You go on to solve this, what's going to be your value? Two raised to power 4 will give me a value of what? Of 16. So this will be 729 over 4 times 2 raised to power 4, which is 16. That will be 16 over 81. This will, 4 will go here 1, and 4 will go in 16, 4. And what's 729 divided by 81? 9. So 4 go here, 81 go here 1, 81 go here 9. I'm left with 9 times 4, my value being 36. And you see how easy it is to solve questions like this. You don't have to fret at all. You don't have to fret at all. All right, so this is where we end for sequence and series under GP. But I want to give you one question. Probably we'll pick that up later. We'll start from there before we delve into our other questions. Can you take it quickly? You can try this on your own. It's under AP. Then when we start the next class, we're going to start from the solution of this particular question, and then we'll delve much deeper into GP, and then we'll complete it with harmonic sequence. All right, this is the question. You were told that the sum of 3 consecutive numbers in an AP is 15. The sum of 3 consecutive numbers. The sum of 3 consecutive numbers in an AP is 15. And the sum of their squares, the sum of their squares is 83. So the sum of 3 consecutive number being 15, and the sum of their squares is 83. The sum of 3 consecutive numbers in an AP is 15, and the sum of their squares is 83. So you are told to find the numbers. Find the numbers. So I want you to do that question personally. Attempt this. The sum of 3 consecutive numbers in an AP is 15. The idea to that is obviously you understand what consecutive numbers means. That means they follow each other. And they said the sum of those 3 consecutive numbers gave you 15. And then the sum of their squares, that means when you squared them, raise them to the power of 2, the sum gave you 83. You're then told to find those numbers. That means find them. What are those numbers? What are those numbers? All right, guys, we'll continue from this particular question in the next class, and then we'll go on to delve deeper into sequences and series. There's still a lot to be done before we go on to harmonic sequence. I really hope you guys enjoyed your time tonight. We'll still be having our class by 9 p.m. That's for everyone. And we'll be having a lot of questions to solve, lots of questions on MI, on several topics. We'll be solving various questions by 9 p.m. So I hope to see everyone there. Make sure you go home to charge up your phones and do whatever you need to do to be present by 9 p.m. All right, guys. Can you give me a feedback very quickly? How do you feel about this topic? What's your understanding level now? Are you much better? Are you a bit better when it comes to AP? We have not done so much in GP. So I understand if you're still having some issues in GP and harmonic sequence. By the end of this class, I think on Wednesday, we should be done with everything on sequences and series. So can I have some feedbacks very quickly? Okay, much better. That's nice. Okay, it's very simple. I love that. Okay. All right. So, guys, I'll leave you at this moment. Seeing you by 9 p.m. Thank you very much. See you by 9 p.m.